Welcome again to next topic, integration. What does it have to integrate this question we have on the board? Now they say integrate exponential 2x cos 4x dx. How do we integrate this type of question? What you do is, let's see shortcut of, or we can use to integrate. You say integrate exponential ax cos bx dx, where a equal to 2, b equal to 4. Let's see how we can integrate the original aspect of it, 4. So let's use, we use the tabular method to do it. In tabular method, we put here cos bx and put here exponential ax. So how do we do it? This means differentiation, while this means integration. That is for tabular method. Now, differentiate this, you will be having minus b sine bx. Minus b sine bx. That differentiate bx, you have b. Then differentiate cos minus sine bx. Now, differentiate this, integrate this, because I have I here. Integrate this, you'll be having 1 over a exponential ax. Now we come again, differentiate this. We have minus b, differentiate bx, it will give you b. Then differentiate sine, it will give you cos bx. Okay? Then integrate this, it will be giving you, differentiate this, we have minus b, differentiate bx times b. If you differentiate bx, you have b. Then differentiate sine, we have cos bx. Then integrate this, you will be having 1 over a square exponential ax. We are trying to derive shortcut. Then we have arrived at exponential cos bx, exponential cos bx. So we stop here. We say this goes to this, then this goes to this, this goes to this, then this goes to this. After you multiply this. Now see what we do. We call everything here to be I. We say integrate I equals to this times this. You will be having exponential as cos bx all over a. Then here must be plus. Once you assign this to this, say plus minus plus. This signs you are putting is constant. Plus minus plus. If you continue putting minus plus and so on. So because it is in 3, say plus minus plus. They are constant. So then you say this times this, it will give you exponential as cos bx over a. Minus times minus plus. So plus b sine bx times this. That will be giving you exponential ax all over exponential ax all over a squared, then b sine bx. Then you multiply these two. If you multiply these two, plus times minus minus. If you multiply these two, it will be giving you minus b times b squared, then cos bx exponential ax all over a squared. So this whole of this times this will give you this. Okay? Then what you now do is, you now say, here I can see this I here. This thing I called I can see it here. I say here is also I. Okay? Then what I will now do is I say, carry this to the other side. I will have integration I will have integration I plus, or as this comes to the other side, I will say plus integration b square cos bx cos I, because we say let everything be I, okay, all over a squared equals to everything here exponential ax cos bx all over a plus exponential ax b sine bx all over a squared. So what you do now is you factorize. You'll be having integration I, because they have it in common, bracket 1 plus b squared over a squared. Then that will be giving you the whole of this exponential as cos bx all over a plus exponential as b sine bx all over a squared. Now, looking for LCM of this, the whole of this is the same thing as you writing this way. A squared plus b squared. If you look for LCM, so you now say integration I will be equal to. Then, if you carry this to the other side, you will be having only integration I. You now say this will be giving you exponential a x cos bx all over a plus exponential ax b sine bx all over a squared. Then see what we now do. We now say taking this to the other side, it will divide everything. That will be giving you, here we'll be having integration I is equals to exponential ax cos bx all over a divided by a squared plus b squared all over a squared. Then you now say plus integration ax b sine bx all over a squared divided by a squared plus b squared all over a squared. So, having gotten this, remember that whenever you have division and you are to remove it, to replace it with multiplication, you'll be having cos bx all over a times, I will invert this, a squared all over a squared plus b squared, then plus, I will now say exponential ax b sine bx all over a, change division to times a squared all over a squared plus b squared. So what we have is that this we cancel only one a, while here this we cancel. This is over a squared, please, a squared. So we now have it that this we cancel this, then this we cancel this, leaving you with 1a. So in conclusion, you will be having that this means we have here to be a, we have here to be integration I equals to a times everything a cos bx all over a squared plus b squared plus b exponential ax sine bx all over a squared plus b squared. So that is what we have here because this b is here, so we give you. Then finally, what is our I? Our I is exponential ax cos bx. We are replacing everything. Now you factorize. We have exponential as in common, bracket a. So we have exponential as, a squared plus b squared. So a squared plus b squared. Then a cos bx plus b sine bx. So that is the shortcut we will use to solve this question. Now let's see how we solve it. To solve this question we say integration exponential 2s plus 4x. We say our a is equal to 2 and our b equal to 4. We use this shortcut. That will be, what is my a? 2s all over. What is my a square? A square is 4. 4 square is 2 square plus 4 squared. 2 square 4. 4 square is 16. 4 plus 16, 20. I'll be writing 20. Bracket. What is my a? 2 cos. What is my b? 4x. Plus what is my b? 4 sine 4x. Then I'll say plus c. Remember why we say plus c is because they did not give us upper and lower limits. So that is how to integrate this. Look at the shortcut we derived, and look at how to apply it. See next video so that you see next question we solve on this with respect to sine. Please don't forget to subscribe to my YouTube channel and like my video as you watch it.